Okay, so just look at over there. Question is saying that the hydrogen react with iodine in a reversible reaction. The reaction reaches an equilibrium if carried out in a closed system. The reaction is given to you. You can see over there. This is the question or equation, and you can see this. The main thing is over here. This energy change, and the energy change is positive, so the reaction is endothermic. We know that we have two reactions over there, and the forward and the backward. So that they are talking about the forward reaction is endothermic. This is endothermic, and then definitely the backward, which is opposite one, is exothermic. The reaction is studied at a temperature of 400 degrees Celsius. Describe and explain what happened to the position of equilibrium. They are asking about position of equilibrium. So we need to answer about position of equilibrium only. We don't need to talk about yield. We don't need to talk about rate of reaction. We don't need to talk about anything else. We just need to talk about position of equilibrium. If the pressure is increased, you can see this, that the question is for 2 marks. So you need to state what happened to the position of equilibrium and why, right? You got 2 marks for this. So we know that the number of moles on the both sides are same. This is 1 plus 1, 2, and over here 2. So there is no change on the position of equilibrium. Simply you can say that there is no effect on position of equilibrium, right? You got 1 mark for this. The correct position or the correct answer, you got 1 mark. And then you need to explain this, why this so, right? So there is no effect on position of equilibrium because the number of moles of gases on both sides are same, because the number of moles of gases on both sides are same. Is that clear, every one of you? Yes, everyone, is that clear?
Yes, sir.
Okay, so let's talk about the next one. They are saying that the reaction is studied at 25 atmospheric pressure. Describe and explain what happened to the position of equilibrium again if the temperature is decreased. So you know that this is endothermic reaction. So endothermic reactions is required temperature. So if you are decreasing this, so definitely it will move backward. So you can say that toward left. What is that screen is visible to all of you?
Yes.
So you can see this that if the forward reaction is endothermic, so you must need to provide them heat, so the reaction will move forward, right? If you're not providing heat, so definitely the reaction is moving backwards. So you can say that if the position, if you are decreasing the temperature, so the position of equilibrium shifts towards left because the forward reaction is endothermic. You need to keep remember, you need to mention the forward reaction. You cannot say that the reaction is endothermic because you need to keep remember that both type of reactions are there, right? So keep remember to mention the type of reaction over there, that the forward reaction is endothermic, right, every one of you?
Yes, sir.
Now it's your turn to solve the question. So here we have one more question almost similar to this. So let's see, can you solve this or not, right? So the third part is not for you because it is the rate of reactions. You just need to solve, but so the first part and second part, which is